Next, we have trees. So trees are a special type of undirected connected graph. Undirected means there's no arrows. So some graphs you will see will have direction. So something like this. A tree will not have any arrows at all. So it's a undirected, connected. So connected, remember, we have no isolated vertices, no loops, no multiple edges, and no cycles. So cycle is basically where we start from one point and end at the other point, covering all vertices on the graph. So if there is a cycle existing in a tree, it is not a tree. So for example, this one, we can start from A, B, C, and come back to A. That's why it's not a tree, whereas this one, it is a tree. Next, we have something called spanning trees as well. So the difference between a tree and a spanning tree is, if this is our parent graph, a tree will include some or all of the vertices. There's no restriction on how many vertices it has to include, but it's sort of like a subgraph of the original graph, including some or all of the vertices. Whereas a spanning tree will include all of the vertices, and usually the application of spanning tree is, let's just say, this is sort of like a map, and we want to work out the shortest path between these different locations. Let's just say we have distance as well. 4, 2, 3, 4, 5, 6, whatever. And let's say we have multiple edges like this. This is an original graph, so it can have multiple edges, but the tree will never have multiple edges. Just like this, and let's say it has a length of 3. So if we're trying to create a spanning tree, essentially what we're trying to do is select the edges that have the lowest weight, usually. But just in general, what we're looking at in terms of specialist maths, mainly, a spanning tree will include every single vertex of the parent graph, whereas a tree will only include some of the vertices of the parent graph. As you can see here, it only has A, C, B, A. This one has all of them. Okay, let's move on.